Hello everyone and welcome back to the channel. Today we are going to explore the ASC function in PySpark which helps us sort data in ascending order. Whether you're dealing with numbers that need to be organized from smallest to largest or text values that need to be sorted alphabetically, sorting in ascending order is a crucial part of data analysis. In this video, I'll show you how to use the ASC function effectively, and we'll go through practical examples to help you understand how it works. So let's dive right in. Introduction to the ASCII function. The ASCII function in PySpark is used to sort a data frame in ascending order based on one or more columns. It is the opposite of the DSC function and operates similarly to the SQL ASCII keyword used in order by statements. Sorting in ascending order is a common requirement in data analysis, especially when you need to arrange numeric data from smallest to largest or string data alphabetically. For example, if you have a list of product prices or sales figures, you might want to use ascending sorting to see the lowest values first, which can help in identifying the least expensive products or the lowest performing sales. Similarly, for string values, sorting in ascending order arranges data alphabetically, which is useful for organizing categories, names, or other textual information in an orderly fashion. The order by function combined with ascending sorting helps present your data in a structured and readable way, allowing for easier comparisons and more intuitive analysis. It is particularly helpful for scenarios where viewing data in a logical, natural order is necessary, such as in financial analysis, customer records, or generating reports that require organized information for better understanding. Overall, using the ASC function in PySpark is a straightforward way to organize your data, ensuring that it is displayed from the lowest to the highest values, making your analysis process more effective and allowing you to draw meaningful insights from your data. Basic syntax. In PySpark, you can sort a data frame in ascending order using the order by function with column name dot ascending. The column name parameter specifies the column you want to sort, and ascending arranges the values in increasing order. This is useful for numerical values, where you want the smallest values first, or for strings to organize them alphabetically. Using order by with ascending allows you to present data in a structured, logical order, making it easier to analyze trends, compare records, and communicate insights. It helps organize data systematically, ensuring clarity in your analysis. Why use ASC function? Sorting data in ascending orders is useful for organizing information intuitively, such as ranking numerical values from lowest to highest or arranging dates chronologically. The ascending function helps make datasets more readable, whether you're sorting prices, ages, or text fields alphabetically. Using ascending allows for easy comparison and logical ordering, making data easier to analyze and interpret. It's particularly helpful for creating reports, identifying trends, and ensuring that your data is presented in a natural structured sequence. Practical examples. They one sorting a column in ascending order. In this example, we are working with the PySpark data frame DF that contains sales data for various items. The data frame has two columns, item and sales. The item column represents the product names, while the sales column shows their corresponding sales values. Our goal here is to sort the data based on the sales values in ascending order to identify the lowest sales values first. To achieve this, we use the order by function in combination with df.sales.ascending. This means that we want to arrange the rows in the data frame based on the sales column from the lowest value to the highest. Sorting sales data in ascending order allows us to focus on items with the least sales, which could help identify areas that may need improvement, such as underperforming products or items requiring promotions. By using the .show function, we can display the sorted data frame. The result presents the items in an order starting from the lowest sales figure and moving up to the highest. This kind of sorting is helpful when we want to get an overview of sales performance, see which products are struggling, or create a report that shows how items rank based on their sales. Overall, this example demonstrates how to use the order by function with ascending sorting in PySpark to organize data from smallest to largest. It provides a clear way to understand and analyze sales figures, allowing for better decision making and effective business strategies. 2. Sorting multiple columns with ascending order. In this example, we have a PySpark data frame DF that contains sales data for different items. The data frame consists of two columns, item and sales. The item column represents product names, and the sales column holds the respective sales values. Our objective is to sort the data first by the item column in ascending alphabetical order, and then by the sales column in ascending numerical order within each item. To achieve this, we use the order by function, specifying both df.item.ascending and df.sales.ascending. By doing so, we first ensure that the items are grouped alphabetically, making it easy to see similar items together in the dataset. Next, within each item group, the sales values are arranged in ascending order, allowing us to see the variations in sales for each product. This dual sorting helps provide a clearer view of how each product is performing compared to similar items. The dot show function is used to display the sorted data frame, which now presents the items in alphabetical order, followed by their sales in ascending order. This approach is useful when analyzing sales data to understand the distribution within each product type, or when generating reports where the data needs to be logically grouped and ordered. Overall, this example demonstrates how to use the order by function in PySpark to organize data by multiple columns in ascending order. Sorting by both item and sales helps create a structured view that is easy to analyze, highlighting trends and enabling better comparisons across similar products. 3. Using ASCII with multiple aggregations. In this example, we are working with a PySpark data frame DF that contains sales data for various items. The data frame has columns named item and sales, where item represents different products and sales contains their respective sales values. Our goal here is to calculate the total sales for each item, then sort the resulting data in ascending order based on the total sales value. First, we use the group by function to group the data based on the item column. By using the aggregate function with some sales, we calculate the total sales for each item, giving us a consolidated view of how much each product has contributed to overall sales. We also use the alias function to name the result as total underscore sales, making it easier to understand. After calculating the total sales, we want to see the results sorted in ascending order to identify the items with the lowest total sales first. We use the order by function with ascending total underscore sales to sort the data, starting with the items with the least sales and moving toward the highest. Sorting in ascending order helps to quickly identify which products are underperforming or have lower contributions, providing insights that could guide decisions related to promotions or inventory management. Finally, we use the dot show function to display the sorted data frame. The resulting data frame shows each item along with its corresponding total sales arranged from the lowest to the highest. This makes it easier to analyze the sales performance of different items, allowing for data-driven insights and more effective business planning. Overall, this example demonstrates how to use the group by, aggregate, and order by functions in PySpark to effectively analyze and prioritize data based on total sales. By sorting in ascending order, we can easily spot trends and make informed decisions regarding products that need attention or have room for growth. 4. Using ASC with column expressions. In this example, we are working with a PySpark data frame DF that contains sales data for different items. The data frame consists of two columns, item and sales. The item column represents product names and the sales column holds the respective sales values. Our goal is to sort the data based on an adjusted sales value after increasing each value by 10%, and we want to arrange the data in ascending order. To accomplish this, we use the order by function along with the XPR function. The XPR sales 1.1 part creates an expression that increases each sales value by 10%. By specifying ascending after this expression, we instruct PySpark to sort the items from the lowest adjusted sales value to the highest. Sorting the adjusted sales values in ascending order helps us understand how a 10% increase affects each product and allows us to see which items have the lowest adjusted sales. After adjusting the values, the dot show function is used to display the sorted data frame where items are arranged based on their adjusted sales from lowest to highest. This type of sorting is particularly useful for scenarios where you want to see the impact of a hypothetical sales increase and identify the items with the least potential growth, which can aid in decision making regarding sales strategies or prioritizing efforts to improve sales performance. Overall, this example demonstrates how to use the order by function with an expression to sort data in ascending order based on modified values. It provides a straightforward way to simulate potential changes and understand how adjustments could impact the overall order of products, supporting effective business planning. 5. Handling null values with ascending order. In this example, we are working with the PySpark data frame df underscore with underscore nulls that contain sales data for different items. The data frame has two columns, item and sales. The item column lists the product names, while the sales column contains their respective sales values. Some of these sales values are null, indicating that the data might be missing or unavailable for certain items. Our goal is to sort the data frame based on the sales values in ascending order while ensuring that the null values are placed at the end of the sorted list. To achieve this, we use the order by function with df underscore with underscore nulls dot sales dot ac underscore nulls underscore last. This means we want to arrange the sales values in ascending order, starting with the lowest values and moving up to the highest while making sure that the null values appear last. Sorting with nulls last is particularly useful when you want to focus on complete data first, as it helps to prioritize records with actual sales numbers, making analysis more meaningful. The dot show function is then used to display the sorted data frame, where the items are listed from the lowest to the highest sales values with any null values appearing at the bottom. This approach helps make the data cleaner and easier to interpret as it avoids null values being mixed in with the rest of the sorted records. By keeping nulls at the end, it becomes simpler to focus on items with available sales data, identify trends, or draw conclusions from the sorted information. Overall, this example demonstrates how to use the order by function in PySpark to sort data in ascending order while handling null values effectively. By placing nulls last, we ensure a more structured and insightful analysis, allowing us to prioritize records with complete information for better decision making. 6. Sorting strings in ascending order. In this example, we are working with a PySpark data frame df that contains information about different items. The data frame has two columns, item and sales. The item column lists the names of the items, and the sales column represents the sales values for each item. Our goal here is to sort the items alphabetically in ascending order based on the item column. To achieve this, we use the order by function with df.item.ascending. This tells PySpark to arrange the rows in alphabetical order, starting with the item that comes first alphabetically and continuing down the list. Sorting items in ascending order is particularly helpful when we want to present or analyze the data in an organized way, as it allows us to see similar items grouped together, making it easier to locate or compare specific products. After sorting, use the dot show function to display the data frame showing the items listed in alphabetical order. This approach is especially useful in scenarios where you need a structured presentation of data, such as generating reports, organizing inventory, or simply providing a clearer view of the items being analyzed. Overall, this example demonstrates how to use the order by function to sort data alphabetically in ascending order in PySpark. This type of sorting ensures that your data is presented in logical and user-friendly manner, making it easier to navigate, analyze, and draw meaningful insights from the information. Thank you all for watching. I hope you now have a clear understanding of how to use the ASC function in PySpark to sort your data in ascending order. Whether you're organizing numbers or text, ascending sorting can be a powerful tool to make your data more manageable and easier to interpret. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more tutorials on data analysis and PySpark. Don't forget to drop your comments or questions below. I always love hearing from you. Until next time, keep exploring, keep learning, and happy coding.